Okay, hello again. Welcome to my mini distance learning lab. So I've built a circuit here. It's got 9-volt battery, and right now it's got 0.9 amperes of current flowing through it. By Ohm's law, V equals IR, so I equals V over R, so that's just 9 divided by 10 is 0.9 amperes. But notice I've got two other resistors up top. Let's watch what happens when I close this switch. Watch what happens to the current in the circuit. Well, that was not, there we go. Notice how it just jumped. In fact, it doubled because my resistance essentially halved by the parallel resistor rules. And in a parallel resistor, the voltage across the battery is the same as the voltage across all those points. And that's how I derived the rules for parallel resistors yesterday. So I'm going to close this switch now. And notice what happened to that current. Once again, it jumped. So now it's 3 times 0.9. And let's look at the mathematics of it over here. Okay, so here I have my parallel circuit, and if I want to get my equivalent circuit, I draw something like this. I've got my 9-volt battery down here, 9-volt battery down here, and I'm going to write this as Req. To actually find that value, I follow the rules for parallel resistors, and that's 1 over Req would be 1 over 10 plus 1 over 10 plus 1 over 10. Well, that's easy. That's 3 over 10. But here's a mistake that students often make. This is 1 over Req is equal to 3 over 10. So what is Req? Well, by mathematics, you cross multiply or you just flip this fraction. So Req is actually equal to 10 thirds, which you guys know is 3.33 ohms. So my equivalent resistance is 3.33 ohms. So if this is 9 volts, if I want to know the current that's flowing through this circuit, this little circuit here, which is a current right next to the battery, I would say this. I is equal to V over R, 9 over 3.3 repeating, and I believe I did the mathematics on that. 9 over 3.3 repeating is equal to 2.72 amperes. 2.72 amperes. Now let's check FET really quick. Look at that. They are measuring 2.7 amps because they are rounding. So now let's go ahead and find the voltage and the current across each one of the resistors so I could find the power. And remember, the power dissipated is equal to, sorry about that, power dissipated is equal to VI or I squared R. Well, in a parallel circuit, it's easy because the voltage across those 2 points is 9 volts. The voltage across those 2 points is 9 volts. The voltage across those 2 points is 9 volts. So how do I find the current? Well, I is just equal to V over R for each of those resistors. So that should not be particularly hard. So I is equal to, well, V is 9 volts over R, which is equal to 10. Oh, well, that's easy. That's 0.9 amperes should be flowing through each one of those branches. So each one of these gets 0.9, 0.9, and 0.9. Okay. Remember, the whole goal is to find what is the power being dissipated, so I need to know the voltage. The goal is to find the power dissipated, so I need to find the voltage and the current flowing through each. And if you look at my circuit here, 0.9 amperes on that top, 0.9 amperes on that bottom one. And if I had an amp meter in there, you would see that one is 0.9 amperes as well. If you add 0.9 plus 0.9 plus 0.9, it should give us 2.7 amperes. Okay, I think that is a good start for parallel circuits. When the numbers start changing, it becomes a little messy, but you follow the exact rules that I have here, and it's not too bad. I'll do combos tomorrow night. Thanks, guys.